Today is going to be our second video on 6.5, the remainder and the factor theorem. So we're going to take it one step further than what we did yesterday, and we are going to not just divide. What we're going to do is we're going to take a polynomial and we're going to write it in factored form. So we're going to find all of the factors using synthetic division. So we start with f of x is equal to 3x cubed plus 13x squared plus 2x minus 8. Until today, if I wanted to factor this, because I have 4 pieces, the only way I could possibly factor would be factor by grouping. I'd group the first two, I'd group the second two, pull out my GCF, x squared, we're left with 3x plus 13, pull out the GCF of 2, I'm left with x minus 4. I see that the inside pieces are not the same, therefore we cannot factor using grouping. When you get to a point where you can't factor something by grouping and you have 4 pieces, what you're going to do is use synthetic division. So this is not necessarily your first go-to, but it's what you're going to do when you can't factor by grouping. We are given that f of negative 4 is equal to 0. If f of negative 4 is equal to 0, that means that x is equal to a negative 4. That is a solution. And we know that if x is equal to a negative 4, we move that over. That means that x plus 4 is a factor. Therefore, x plus 4 is a factor. It's super important that you are able to go from solution form to factored form and back and forth. Be able to go in both directions. So we are given that f of negative 4 equals 0, so x equals a negative 4, that's a solution, and we're going to use synthetic division, and we know when we use synthetic division, we use the solution. When we use long division, we use the factor. So we use our solution of a negative 4, we set up our synthetic division here, we double check our exponents, 3, 2, 1, 0, we are good, we don't have to fill in any missing numbers, our coefficients of 3, 13, 2, and a negative 8. And review from yesterday, we bring down the 3, we multiply, a negative 4 times 3 gives us a negative 12. When synthetic division, we just combine the two together, so 13 minus 12 leaves us with 1. Negative 4 times 1 is a negative 4. 2 minus 4 gives us a negative 2. Negative 4 times negative 2 gives us a positive 8. A negative 8 and a positive 8 means 0. And remember, in synthetic division, if we have 0 as a remainder of 0, if we have a remainder of 0, means it's a factor. So if it divides evenly with no remainder, that means that it's going to be a factor. If you have a remainder left over, you can still divide it, but whatever you're dividing by is not a factor of that polynomial. So we know that if we're going to write our answer in factored form, we've got f of x. We just found our first factor, solution of negative 4, which is x plus 4. And we actually knew that already because that was given to us. Now we started with 3x cubed. We started with the third degree, so when I factored out the x, I am left with a second degree. So that's 3x squared plus x minus 2. We are now left with a quadratic. We know how to factor a quadratic. We're not solving the quadratic right now, we are factoring it. So when I have a quadratic, we know that we have to factor. And when we look at our first term, there's no GCF that I can pull out. And our first term is not a 1, which means we have the Batman. So we've got 3 times a negative 2, which is a negative 6. Pull down 3x squared. Pull down a negative 2. Two numbers that multiply to a negative 6 and add to a positive 1 is a positive 3x and a negative 2x. Now we use that factor by grouping. We pull out our GCF, and unlike how we started, we see that factoring by grouping is going to work this time. So we pull the two GCFs together. 3x minus 2 is our first factor, and x plus 1 is our second factor. We can go ahead and combine that with the first factor that we found. found we have taken our third degree polynomial and we have factored it using synthetic division. Alright, we're going to take that even a step further, and we are going to find all of the zeros. And we know that zeros is another word for roots, which is another word for solutions. And if it's a real solution, it's an x-intercept. So how many solutions should we expect to find? And this again is going to be a review. In this case, we have x cubed plus 6x squared plus 3x minus 10. I should expect to find 3 solutions. And remember, we look at our degree for that. And the degree is the highest exponent that you find, and 3 is the highest. So I should expect to find 3 solutions when I'm done. And in order to get those solutions, we are going to factor. You must factor and then solve. So again, if we were to try factoring by grouping, it wouldn't work. We're not going to go through all of the work to show that, but it's not going to work, so we're going to use synthetic division. And I'm giving you that -5 is a solution. So that's the number that I'm going to put on the outside. We set it up. Our coefficient's 3, 2, 1, 0. We don't have any missing numbers. Always double check for missing numbers. If you don't fill that 0 in, it's going to change everything. Bring down the 1. -5 times 1, -5. 6 minus 5 is 1. -5 times 1 is -5. 3 minus 5, -2. -5 times -2 is a positive 10. And we've got a remainder of 0 again. Remember, if I'm telling you something is a solution, if it is a factor, you should expect to get a 0. If you don't get a 0, you made a mistake. There is a huge difference between just dividing and factoring. If you divide, you can have any remainder you want. But if you're trying to prove that that's a factor, you must have a remainder of 0. So we started with an x cubed. We factored out 1, so this is going to be 1x squared plus 1x minus 2. We're down to a quadratic. Once we've got the quadratic, we can factor. So we're looking for two numbers that multiply to a -2, add to a positive 1. That's a positive 2 and a -1. So now we have all of our pieces to write factored form. We were given a solution at -5, which means x plus 5 equals 0, which means that we are given a factor of x plus 5. And then after we factored out that solution of a -5, we were left with a quadratic, and we factored our quadratic as x plus 2, x minus 1. So we just factored a third degree polynomial. But we wanted to take this one step further, and we wanted to solve. If we are solving, we use ZPP, and we set it equal to 0, just like we did with a quadratic, which means we have x plus 5 equal to 0, x plus 2 equal to 0, and x minus 1 equal to 0. So we've got 3 solutions here. One at a -5, one at a -2, and one at a positive 1. Alright, we are almost done. We have one more problem to go. When we turn over to the back side, I'm telling you that 1, 0 of f of x is x cubed plus 3x squared minus 7x minus 6 is x equals 2. What I want you to do is find all of the other zeros of the function. I want you to start this one on your own. So I want you to do the first step of synthetic division by yourself. Once you're done with that, go ahead and press play again and see if you did the synthetic division correctly, and then we'll do the rest together. Alright, so we were given that x equals 2 is a solution, so that goes on the outside. We set up our synthetic division. After we synthetically divided, we were left with 1, 5, 3. We started with an x cubed, so we are left with x squared plus 5x plus 3. And we found that that was not factorable. So, for factored form, we have the factor that was given to us. If x equals 2 is a solution, that means x minus 2 is our factor. Now we could not factor this any further, so our second factor is x squared plus 5x plus 3. And that's as far as you can go for factored form. But we can go further when we are solving. Remember, when we solve, we go ahead and plug in 0, and we use ZPP. So we've got x minus 2 is equal to 0, so we've got a solution at 2, which was given to us. When we look at our other piece, we've got x squared plus 5x plus 3 is equal to 0. Now you can't forget everything that we've been doing. This is a quadratic. If we are solving a quadratic, we know we have so many methods we can use. Quadratic formula, completing the square. Factoring was one of them, but we weren't able to factor it, so that one is no longer an option. So we're going to use the quadratic formula. Our a is 1, our b is 5, and our c is 3. So the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. When we break that down, inside of the square root sign, we end up with 25 minus 12, which is the square root of 13, all over 2. What you want to be careful about here is, what do your directions say? What am I asking for? If I ask for your answer in exact form, so my exact answers would be x equals 2 and x equals a negative 5 plus or minus the square root of 13 over 2. There are my three solutions. I've got 1 at 2, and then I've got 2 over here, one when I add root 13 and one when I subtract it. If I ask for rounded answers, remember exact answers have no decimals. Rounded answers would be x equals 2. I would plug this into my calculator and get a negative 0.70 and a negative 4.30. So again, read the directions, make sure that you're following what's being asked of you. And what I would do right now if I was you is I would double check putting the quadratic formula into my calculator and make sure that I'm able to get the answers a negative 0.70 and a negative 4.30. Since I have more than one piece on top, I've got to make sure if I put it in all at once, I put parentheses grouping my numerator together and then dividing by 2. Alright, and that's all for our second day of 6.5.